We often talk about military tech in terms of firepower, how big is the boom. But when you look at the landscape today, the real currency isn't yield, it's time, or maybe the theft of time. We're getting into a situation where the window to make a world-ending decision is shrinking from, 30 minutes to maybe 5?
It's the compression of the ODA Loop Observe Orient Decide Act. If you can move faster than your opponent can even think, you've already won. And that is exactly what this hypersonic arms race is all about.
And that brings us right to the stack of research we have for today. We're looking at a really pivotal report from the Jamestown Foundation's China brief.
A dense one.
It's a dense piece, yeah. It's called Updated Chinese Hypersonic Weapons Development, and it's a deep dive into one specific system, the DSZF.
Which U.S. intelligence, they used to call it the Wu-14 back in its prototype days.
Right. But what really struck me reading this wasn't just the speed, the Mach numbers. It was the feeling that we're watching a replay of the dreadnought race from the early 20th century.
How so?
Everyone knows the old rules are obsolete, so there's this mad scramble to define the new ones. And this report, it highlights this very specific timeline, 2014 to 2016, where it really feels like the U.S. blinked and China just sprinted.
Yeah, that's a pretty fair characterization. The report actually contextualizes this with a huge organizational shift in Beijing. On January 1st, 2016, the People's Liberation Army Rocket Force, the PLARF, was elevated to a full-service branch.
Okay, which sounds like boring corporate restructuring. But in military terms, that is a huge deal.
It's massive.
They used to be the 2nd Artillery Force, which, it implies they're a support branch. Now they're sitting at the same table as the Army, the Navy, the Air Force.
Exactly. It was a signal that missiles aren't just big cannons anymore. They are a primary strategic arm. And this elevation, it coincided perfectly with the aggressive testing of the DFZF.
So they put their money where their mouth was.
They centralized their best engineers, poured in resources, and, essentially bet the house on these hypersonic glide vehicles as the key to neutralizing U.S. power in the Pacific.
Okay, so before we get into the whole geopolitical chess match, we should probably clarify the physics here, because hypersonic is a buzzword that gets thrown around a lot.
It does.
I mean, technically, it's just anything faster than Mach 5. What is that, like 3,800 miles per hour? But ICBMs have been doing that since the 60s. The Apollo capsule re-entered at Mach 25. So why is the DFCF so special?
You're right. Speed alone isn't new. The novelty here, it's all about the trajectory.
Okay.
Think of a standard ballistic missile, an ICBM like a fly ball in baseball. It goes way up into space, follows this really predictable arc, and then comes straight down.
Which makes it easy to track. Once your radar picks it up, the math is simple. It's here now, so in 20 minutes, it'll be there.
Precisely. We spend billions on missile defense systems, like the AJ or the Aegis system, that rely entirely on that predictability to calculate an intercept point and, send a bullet to hit a bullet. But the DFZF, it doesn't act like a fly ball. It uses what's called a boost glide trajectory. A rocket boosts it up, sure, but instead of leaving the atmosphere entirely, it sort of pushes its nose down.
So it's like it's skipping off the atmosphere.
That's a great way to put it. It glides along the very upper edge of the atmosphere, maybe 40 to 100 kilometers up. And this does two critical things. First, it stays below the radar horizon.
Because the Earth is curved.
Exactly. Ground-based radar can't see things that are hugging the surface until they're relatively close. An ICBM pops way up high, so you see it early. This glider stays low, hiding behind the planet.
So by the time your radar actually sees it, it's already about to hit.
You might have seconds to react, not minutes. And then comes a second problem. It can maneuver. This thing has control surfaces. It can bank. It can turn.
So you can't predict the landing spot. You can't solve the equation because the variables keep changing mid-flight.
And that right there is what renders the current generation of U.S. missile defenses in the Pacific, well, arguably obsolete against this specific threat.
It's the classic sword versus shield dynamic. We built a very expensive shield, so they just built a sword that flies around it. Now, the Jamestown report, it draws this really sharp contrast between how China approached this versus the U.S. And it seems like a classic case of better is the enemy of good.
It really is. The report outlines the big three approaches, China, Russia, and the U.S. The U.S. program, the X-51A Waverider, was aiming for the technological holy grail, the scramjet.
The air-breathing engine.
Right. The supersonic combustion ramjet. It scoops up oxygen from the atmosphere at insane speeds and burns it. In theory, it's incredibly efficient because you don't have to carry your own oxygen like a rocket does.
Right.
But the engineering required to keep a flame lit in a supersonic airflow is, people compare it to keeping a match lit in a hurricane.
So the U.S. went for the Ferrari engine. It's complex, it's elegant, super high performance.
And a super high failure rate.
Yeah.
The X-51A had a 50% success rate, and the program effectively ended in 2013. Meanwhile, China looked at the problem and basically said, we don't need a fancy engine, we just need to glide.
The boost glide method. Just strap a glider onto a rocket you already have.
It's simpler. It's brute force physics. And the report card in this analysis proves it worked. Between January 2014 and April 2016, China conducted 7 tests of the DF-ZF.
7. That is an incredibly aggressive schedule. That's what, 1 every 4 months?
On average, yeah. And 6 of them were successful. That's an 83% success rate. So while the U.S. was debating the next generation of concepts, China was out in the field, launching hardware, gathering data, and just iterating.
The report mentions the 10th Research Institute under a China Aerospace Science and Industry Corporation. It sounds like they put the entire effort there.
And that's a key insight.
Mm-hmm.
In the U.S., defense development is, it's often spread across multiple contractors, different branches of the military, various committees. It's a very fractured system. Mm-hmm. The report suggests China took a Manhattan Project approach. They put the aerodynamics team, the materials team, the guidance guys, everyone under one roof at the 10th Institute.
Which dramatically shortens the feedback loop. If the chip doesn't fit the frame, you just walk down the hall.
Exactly. And that centralization is why they could launch 7 times in 2 years. They achieved technological surprise, not because their science was fundamentally better, but because their whole process was just faster.
This leads us to the part of the report that I found genuinely gripping, the detective work. We have these tests, mostly successful, but the one failure, the second test, that actually gave us the most information.
Debris analysis is a fascinating field. When a test fails, well, gravity takes over and pieces rain down. In this case, the wreckage didn't match what Western analysts expected to see.
The assumption was that China would launch these on their DF-21 missile, right? That's their workhorse medium-range ballistic missile. It's solid-fueled, it's mobile, it's reliable.
Correct. Solid fuel is the standard for modern tactical weapons. It's pre-packed. You drive the truck out, you raise the tube, you fire, it's quick. But the debris from the failed test showed components from a Long March 4C rocket.
Which is a liquid-fueled rocket.
And that changes everything. Liquid fuel is old school. It's volatile. You have to fuel the rocket right before launch. It takes hours. And in Chinese military doctrine, liquid fuel is almost exclusively for their heavy ICBMs, their nuclear deterrent.
So wait, we have a conventional glider seemingly strapped to a nuclear-associated launch system.
It creates a massive interpretive problem. There are 2 theories. Theory A is the innocent one. The glider was just really heavy, and they needed the Long March's power to get it up to speed for the test. The operational version will use solid fuel.
Plausible. It's just a test mule.
It is. But Theory B is the nightmare scenario. Theory B suggests the DF-ZF is designed to sit on top of these rockets because it's intended to deliver nuclear warheads.
Okay, so that gets us into this idea of strategic ambiguity. If I'm a radar operator in Okinawa and I see a high-speed object coming in, and I know China puts nukes on liquid rockets and conventional warheads on solid rockets, but now they've mixed them.
You have absolutely no idea what's coming at you. Is it a conventional strike aimed at taking out the runway? Or is it a nuclear strike aimed at taking out the city?
And if you guess wrong...
If you guess it's conventional and it's nuclear, you lose your fleet. If you guess it's nuclear and you fire back with your own nukes, you've just started World War III over a conventional skirmish. This ambiguity, it destabilizes the entire concept of deterrence.
Because it forces the other side to assume the worst.
Always assume the worst.
It seems like a dangerous gamble for Beijing, though. Wouldn't they want us to know the difference so we don't accidentally launch on them?
You would think so. But from their perspective, the ambiguity is the deterrent. If the U.S. is terrified that any small conflict could instantly go nuclear, the U.S. might just hesitate to intervene in a regional conflict, say, over Taiwan.
Let's talk about that. The report uses this term, decapitating strike. It sounds gruesome, but in military terms, it's all about command and control. How does the HGV fit in?
Modern warfare is about systems, not just individual units. China's strategy is often described with these assassin's mace weapons capabilities designed to hit the enemy's biggest weak points. The HGV is the hard kill component of that.
As opposed to a soft kill, which would be something like a cyber attack.
Exactly. In a conflict, the first move is probably a massive cyber attack to blind U.S. sensors, disrupt comms. That's the soft kill. But cyber is temporary. You still need to physically destroy the command centers, the radar sites, the carrier groups. That's the hard kill.
And because the HGV is basically uninterceptable, it guarantees that the hard kill lands.
It guarantees it. A decapitating strike means taking out the brain of the U.S. military in Asia. And the report mentions specifically the PLA brigades that cover Taiwan and the South China Sea. If you can wipe out the command post in the first 15 minutes of a war, the rest of the U.S. forces are fighting blind.
And the range extension is a huge part of this, too. The report notes that just adding a glider to a missile extends its range by, 500 to 1,000 kilometers?
Think of it like skipping a stone across a lake. The initial throw gives it energy, but each skip lets it travel way further than if it just plunged into the water. By gliding, the DFZF extends the reach of China's missiles deep into the second island chain.
And that means Guam.
That means Guam. Guam is the central logistics hub for the U.S. and the Pacific. It's where the bombers are, the supplies, everything. If China can credibly threaten Guam with a weapon that can't be stopped, they have effectively pushed the U.S. Navy back thousands of miles.
So, going back to the tech for a second, we mentioned the U.S. struggled with the scramjet. Is China just sticking with the glider, or are they eyeing that engine tech too?
Oh, they aren't standing still. The Jamestown report highlights a specific event, the China Aeronautical Science and Technology Conference. They gave a high-level award to a developer named Wang Xinggu for the successful development of a scramjet engine.
So they have the glider working, and now they claim they have the engine working.
They claim to be the second nation to master the technology. Now, climbing it and deploying it are very different things, of course.
Yeah.
But if they combine them, if you put a scramjet engine on a hypersonic glider, you don't just have a regional weapon anymore. You have a global one.
Because the engine lets it fly under its own power, not just coast on momentum.
Correct. That would give them a prompt global strike capability.
Yeah.
Very similar to what the U.S. was aiming for in the early 2000s. And given the speed of their testing cycles, we shouldn't assume it's 20 years away. It could be 5.
It really feels like this report is documenting the end of an era, the end of U.S. invulnerability, in a way. For decades, the U.S. operated with the assumption that we owned the skies and we could shoot down pretty much whatever came at us.
That era is over. The dominance of the U.S. missile defense shield in the Pacific has been, well, it's been eroded. The DFZF is designed specifically to exploit the physics of radar horizons and maneuverability that we just haven't solved yet.
So, summarizing our deep dive today, we have a weapon that uses the curvature of the Earth to hide. It was developed at breakneck speed. It carries a terrifying risk of nuclear ambiguity. And it effectively pushes the U.S. safety zone back to Hawaii.
That covers the tactical situation, yeah. But I want to leave you with the psychological implication of all this speed. We touched on it at the start, but it really bears repeating.
The theft of time.
Right. In the Cold War, there was a kind of grim stability. If the Soviets launched, we had about 30 minutes to confirm, call the president, get a decision. It was terrifying, but there was a process.
You had time to double-check the radar, make sure it wasn't a flock of geese.
Exactly.
Yeah.
With hypersonic weapons deployed regionally, say in the Taiwan Strait, that window just collapses. We're talking about flight times of maybe 10 to 15 minutes. But because of the radar horizon problem, the actual detection time might only be 3 or 4 minutes before impact.
3 minutes? You can't even get the president on the phone in 3 minutes.
You can't. Which means the authority to launch a counterstrike might have to be delegated down to local commanders or to automated systems.
Which introduces the risk of an algorithm starting World War III.
It creates a use it or lose it mentality. If you think you're under attack and you know you can't defend against it, your only real option is to launch your own missiles before they're destroyed in their silos. Hypersonic weapons put the whole world on a hair trigger.
It's a sobering thought. We're building weapons that are faster than our ability to think about how to use them.
And that is the arms race of the 21st century. It's not just who has the biggest bomb, but who has the fastest ODA loop.
Well, on that cheerful note, we're going to wrap up this deep dive. It's a complex topic, but understanding the mechanics, the why behind the what, it really makes the headlines make a lot more sense.
Absolutely. The physics dictates the strategy.
Thanks for listening. We'll catch you on the next deep dive.